Good morning. Well, actually, we're 9 minutes into the afternoon where I am here. Today, I'm going to take a break from doing administrative stuff on stream, which is, is what it is. And I'm going to work on the YT Interactive Data Visualization project. So, a couple things about this. The first is that there are a bunch of pull requests that some of them are from me, some of them are from Chris, that haven't been reviewed, and I'm going to try to get to those today. The other thing is I'm actually going to test out this pull request Chris issued just the other day, where he managed to get volume rendering working in spherical coordinates. This is super exciting and awesome work, Chris. I'm going to test it out, try to review it, and see where it can go from there. All right, let's get started. So this is my Visual Studio Code window. Here I've got my terminal. The first thing I'm going to do before I get any further is I'm going to show what it actually looks like to do volume rendering. Here. So what it does is it loads up all of the data, dumps it all onto the GPU, and then we've got this little GUI here. This uses DRIM GUI, which is a pretty great framework. If you've seen any of my previous streams, you've seen me work with this. And it's a little bit slow because I'm running OBS. Generally, I get really good frame rates on this, but in fact, as I'm doing this, it's hilarious. The frame rate on OBS is dropping dramatically. I'm watching it and it's taking 14.7 milliseconds to render a frame, even though I'm just sitting here and it's not doing anything. So let's take a look at if I quit out of that. Now it's tossing itself back up to about 30 frames a second, so that's good. It's pretty intense on the graphics card. There are undoubtedly ways that I could make that better. I don't know them, maybe Chris knows them. But we're basically running a paint operation here. Although it only paints when the scene changes, so I don't know. We'll think about that in a little bit. Let's take a look at where we're at with the pull requests. Let me pull up the project page. All right. So some of these are by me, some of these are by Chris. I think maybe what I should do is go back and try to close up a couple of the really old ones that are basically ready to go. So this one is the, oh yes, okay. So what I tried to do is I tried to set up a windowing system with borders and whatnot in between them so that you could have multiple different displays going on at the same time. So let me go ahead. Looks like got pollute. Oh, you know why? I think, let's see, can I disable white space on this? No, I cannot. I think that I saved this inside VS Code and it applied a linter to it. And so some of this white space change was not actually functional. The main thing that did happen here is this addition of a display border. So let me go ahead and comment that. I think that's the only new shader. Yeah. So what this does, this pull request, is it sets up draw boundaries for different components. This lets you have multiple different things visible at the same time. I don't think I have an example for that, but it's not that incredible or amazing, but it does provide some utility in some cases. Now, if you're running with a reasonably small data set or a reasonably small window, and here my window is not actually that big. Let's see, do we have any examples of this? Let's see, that's the border. What do we call it? We call it the region. Looks like I no longer have any examples. Oh no, there we go. No, that's not an example. I must have wiped them. Let's see if I got any there. Here we go. So what it does, it sets up. Oh goodness gracious, that's actually really old, isn't it? Huh. This is curious. When did I? Oh, all from 2020. Oh, good for me. I'm going to go ahead and create an example here. So, oh, you know what? Did I put one in the conversation? Of course I did not. Okay, let's make one. Let's do AMR volume rendering. Let's make a copy. How do I make a copy? See, some of this stuff is a lot easier in VS Code for me. Some of it is a lot harder. Save as, there we go. In examples, multi-view rendering. Let's call it that. All right, so we add our scene. Let me check here, because I think what we then need to do is add a second display component. So let's do here, and then before rc.run, sg.scene. Yeah, there we go. You know what? Let's do it here with the. Let's take particle rendering. We'll import that into it. Oops. Don't know how to do this. There we go. All right, so here we've got our particle rendering. Let's go ahead and add a particle rendering down here. But our particle rendering, we are going to have sg.components 0.display bounds equals 0.5, 0. Sorry. Let's do this one on the left-hand side, 0.0 to 0.5, 0.0 to 1.0. I think it goes xy. And now let's do pren.display bounds. And here, this one's going to go from 0.5 to 1.0. So let's see what that looks like. So in principle, this should now have two different particle have a particle rendering on one side, and on the other side should have the. Nope, of course not. Let's see if. Oh, haha. Gotta import that. Okay, so now it does do the drawing. Let's see if we can get the particle rendering. Okay, so that actually does work. You'll note that the camera is shared between the two. Let's see if I can get... oh, right, of course. All right, well, let me go ahead and add that. And then I think I'm going to mark this no longer as work in progress, because it doesn't actually change all that much. And then I'm going to mark this as ready for review. This works to the extent that I'd like it to. And there's an example. Okay. So let's call that one worked on. Variable Mesh Explorer. Oh, I remember working on that. I think I even worked it on stream. Spherical volume rendering refactored. That's the one I eventually want to look at. I'm going to look at this, add some camera adjustments. Got a few new buttons for the camera. Let's see. Ah, yes. This sets up, let's see, this is PR156. This one actually might be pretty close to done. So now this one doesn't do that much because the purpose of it is to add just a couple new buttons for managing the way that the camera can be adjusted. So we've got our camera here, X up, Y up, Z up, outside, center. See, it doesn't do that much. I would say that this is basically set. I do think one nice thing might be to have a little adjuster for how much the scroll wheel does. So let's see if we can do that. Camera. This is the trackball camera. It'd be nice if we had a flying camera as well and that you could switch between them. I'm not going to do that just yet. Depause, offset position, move amount. So let's see where we use that. Wait, is there a way to do that here in VS Code? I bet there is. Find all references, but it's not well typed. Let's see what it comes up with. That wasn't any faster than grepping. All right, let's see. Where do we handle our interaction? Let's see. Events? No. Scene? Yeah, that's right, because we do this all inside the Piglet scene. Inside the Piglet context. All right, so let's see. On mouse press, on mouse drag, on mouse scroll. Here we go. All right, so let's add on to the camera. Does this have position? This one is the one that has. It does not have. Well, no, it does. Delta. let's call it scroll delta is equal to traitlet's float 0.1. Okay. So now camera dot scroll delta. Nope. So now we should be able to set up wherever wherever we draw our GUI. So I think that's in simple GUI. Here we go. And that's all on the same line, but here, attribute and camera composition. So here we'll do this. Values equals imGUI dot input. No, near plane, far plane. Those are raw values. We want a slider. So let's see. Where's the slider? Slider float. Let's see. We'll do that here. We will say scroll delta. And where do we set the attribute? Yeah, I guess we actually do the attribute there. We don't need to put that inside our hold trait notifications. So here we'll do slider float, GUI renderer scene. Do we have all of that stuff? I'm not sure we do actually. Oh no, that's not what we need. Scroll delta. There we go. No, we don't want this. We want it to go 0 to like. Let's do all the way down to. Yeah, there we go. Scroll delta will allow it to go all the way down to 0.001. We will say underscore comma. So let's do a log. Log scroll delta. We want this to go all the way down to from -8 to -2, just like with our log scale. There's no really reason for that to be. Scene.camera.scroll delta. Okay, there we go. Okay, so now let's see if that changes it, or if it changes it in a way we like, at least. Okay, once again, the frame rate's going to drop a little bit. Ooh, I forgot to import math. Should probably go at the top. Yeah, there we go. Okay, -8's probably too much, but let's center. Now if I scroll out, yeah, I can get really fine-grained. Again, I want to note that normally I would get a lot better frame rate, but because I'm asking a fair bit of the computer right now, it's going a lot slower, both locally and uploading. Okay. That'll do, I think. Let's change this, because in theory, it could go to really low values, but I think in practice, oh, and it shouldn't even be that. It should be like 0.0. In practice, we're never going to get to, there won't ever be utility in having extremely fine grain because everything's going to be in single precision, at least for now. Okay, let's do the center. Yeah, that looks all right. Okay. Okay. One second. There we go. Okay. I think that's mostly, let's see, what else did I want to do with this? Switching which camera is enabled is not really within scope of this. We just want a couple different buttons. But we do need a fly around camera. That'll have to wait till later. So let's see, can I edit the PR from in here? Let's see. It's real nice review stuff, but not quite what I wanted. I've added the ability to modify the scroll wheel delta as well. I think this is ready to go. Okay. I don't know what this one is. Fixed positioning. Oh, that's an issue. Not going to work on the issue right now. Let's take a look at this. Alright, now let's take a look at the description that I left. So what this ideally does is it allows you to run compute shaders. Oh. Yeah. Not sure I'm ready to work on this right now. Because yeah. Because the example doesn't totally work. The block histogram annotation doesn't display. Really what we need to do is draw it directly into an image, but where I got stuck in the past was with computing all of the axes. Well, let's see. So it does all the atomic adding. Computer shader program pulls it out, links them, runs them, just doesn't draw anything. Okay, so let's see. Let's take a look at that one. I'm going to merge this with upstream. Because there were a couple other things that I wanted to pull out of it. So let's see. What can we get back from this? In theory, if we can get it to compute the histogram, I should be able to pull the data out of whatever the destination texture is and see that. So let's take a look. Why does that say locked? Oh, because that's a preview of upstream. Okay, let's see. See if we can actually just get it to run. And if we can, I'll pull the histogram out. Key error, block histogram. All right. Fragment shader default. Oh, right. Okay. Let's see if we can do a pass-through. Component shaders. Okay, curve rendering, multi-curve rendering, block rendering. Yeah. Well, let's go ahead and add it. Sure. So I think we do this with the compute value, but let's check. Got the compute uniforms. Let's just make sure. That it does that. So it should run the compute histogram. It should run the compute shader first. All right. Component shaders. Block histogram. Well, I spelled it wrong, so there's that. Let's make sure that it's all in the right place. Block histogram has no attribute set uniforms. Well, yeah, it's a scene annotation. But I suppose Yeah, I suppose we probably need to do that because I think they all require. Let's do text annotation. Scene annotation. Set uniforms is just a pass. Can probably do that here as well. Okay. So it looks like it's not calling the compute on the program. So why is it not calling the compute on the program? Oh, probably because draw is not. Let's see if that does it. Oh, good. Now we're actually getting somewhere. Okay. Bind as image. Invalid enumerant. Ooh, hope this isn't because my graphics card is old. Bind image texture. Invalid argument. Error equals 1280. GL bind image texture. Now I always go to the Chronos website for this, although I think that docs.gl is better. Alright, so invalid. Enum if access or format is not one of these supported textures. So access and format are the last two. So 0, 0. Yeah, those are not. I guess I need to specify the access. It's going to be write only. But I thought that was, yeah, image mode. So why is, hold on. That's after it runs. Did it catch another error and then, no. Okay, so we've got how we got here. Now we depart. Why isn't that inside? Huh. Hey, Mike. pops up. Alright, now let's see where we got to. Found the output image texture, but it doesn't run the compute. But hold on, doesn't this need to be inside the... I think it does. So that might be the problem. Well, maybe not. We got to dispatch. Did we finish the dispatch? I don't think we did. Oh, invalid operation. Self bins. Awesome. Wait, why am I dispatching compute on self.bins? Let's see if this works. Is it XHTML? Yeah, there we go. Num groups X, num groups Y. Alright. Oh. If any of it's greater than or equal to the maximum word count for the corresponding dimension. Oh, that's invalid operation, though. No active program for the compute stage. Yeah, I never bind the... Alright, let's go back here to the one of my usual fragment shaders. I think draw gets... Oh, no, that's not a good one to do. Let's do the box. So here... Where do I... So, inside run program, I enable the compute program. I set the compute shader. Oh, self.recompute. Here. I guess I don't need this in the draw. So with the output data bound, it should call compute shader there should be a compute shader active, but because I was calling it from inside draw, it wouldn't have. Okay, good. The compute shader trait of a block histogram instance expected a shader, not the string block histogram. Okay, well, that should be straightforward enough. Let's see, that'll be inside shader support. Shader objects, okay. So this is validating my traitlets, compute shader program, self.compute shader. Self.compute shader is a string, but my traitlet support should figure out how to address that. So shader is a shader trait, shader type compute. So it should be able to identify so validate shader should be getting called. Shader type, you know what, let's do this. Yeah, there we go, shader info. Let's compute the, let's see if we can get it to actually execute. So what's happening now is I've got this system for setting shaders that utilizes traitlets and traitlets validation. And what it tries to do is it tries to take strings and convert them into what we need. So key error, compute shader. All right, shader type equals compute value equals block histogram. Okay, so that suggests to me that really what I did earlier, where I had this shader list and component shaders and all that crap, that's not actually what I needed. What I needed was at the top, so you see we've got this fragment shader. Let's see, can I uncollapse that? And I've got vertex shaders, geometry shaders, and then there are component shaders. What I need is I need to move here, compute, and then I'll have block histogram. And it looks like that guessed everything correct. So now I'll have this. I might need to have that component shader back, but there might already be one that just lets us do pass through. Yeah, it's probably going to throw an error. Yeah, block histogram doesn't exist. So instead, let's see, is there a pass through? No, let's name one. There we go. Just pass throughs. And so for the block histogram, let's make this. See if that'll do it. So now we're setting the block histogram. Key error compute. Enable a null shader. All right, let's see if I got my debug output. Oh, check that out. It's actually a compilation error. That's nice. So let's see. I can't remember if the block histogram does all the default includes. Header Inc. includes version 330. Let's try just upgrading that. sure that'll work, but it might. I don't know what might break if I jump to version 420 from 330. Looks like another compilation error. Yeah, that thought occurred to me as well. It's also my birthday, so of course I think about that a lot. Oh, good, we get to go up to 430 and avoid any further discussion of this. Thanks for coming by, Paul. Come on. So I'm getting all this null compute header stuff. Undefined variable GL workgroup chord. What? Alright, so I guess really what I'm seeing is that when I checked in my earlier histogram compute shader, that did not work. So it had a lot of bugs in it. GL workgroup. Let's see, what's the correct one? It's ID. Where did I get chord? Maybe this is some of that nonsense AI crap. Did I use an AI thing on this? I hope not. Let's see. GL num workgroups is real. Let's see, where's max val defined? That should be defined inside known uniforms, but it's not. Let's just set it all to 0 and 1. Actually, wait, do I set the uniforms here? Block histogram.py. Let's see, what are my compute uniforms? Set uniform min underscore val. That's the problem. Max val minus min val. All these linear scalings are just wonderful. All right, so min val and max val, undefined variable u histogram. Image load u histogram. That should be the output value. Which, let's see. The output value is going to be my texture. Why am I binding as image in 0? Let's see. I guess this is still binding 0. So let's see. Layout. What do I set the layout to be? So bind as image, GL write only. By default, it's R32F. Looks like target by default is 0, but that's an image texture. Is that the same texture unit? Yeah, so let's just bump that up to 2 so that we don't overlap. Enjoy. Have a fun bike ride. Write only uniform image 2D, yes. That's a 1D, all right, so 1D. Still getting compilation errors. Atomic add vec4 int. Wait, only qualified actual parameter 1 cannot be a read qualified parameter. I guess it's read write. Alright, let's see. Atomic add performs atomic addition of the data to the contents of the memory and returns the original contents. I don't actually want the original contents. Alright, let's see. Alright, image 1D, uniform, atomic add. Let's see, what do I need to define it as? Yeah, we can't use write only. Can I just say uniform sampler? Let's try. Looks like I cannot. Oh, because it's atomic add takes in out int memory and int data, but this is a vec4. I don't want that to be vec4. Why is that vec4? Why did I... That's supposed to take the memory, so... Yeah, this is not what I want. It'd be nicer if I had a buffer, but... Looks like what I need to do is not use atomic add at all, but instead load it with the texel coordinate. See, for a lot of people, this stuff comes very easily. For me, it doesn't. And so I have to walk myself through really carefully the different types of shared variables. And so, let's see. If I do image atomic add, that I believe will do it. But it might have issues with the image 1dx int int. What is image 1d 1 by 32? How to atomically add vectors and fragments? No, that's not what I don't want that. Let's try going back to write only. So this is R32F. Maybe that's the problem. Because the number of bins I think I set to, oh yeah, bins is 64, so that's not where the 32 is coming from. Here we go. Pass it in like a layout.